Auzubillahiminash-shaytanir-rajim. Bismillahir-Rahmanir-Rahim. My name is Tanvir Khan. I'm the student of Mechanical Engineering Department, Universitas Indonesia, Depot campus. Today I'm going to present the 33 evaluation criteria of DAI5 framework for final project. So let's start. My final project title is Predicting Stress and One-Dimensional S275 J0 bar elements using artificial neural network coupled with the DAI5 framework. So I will start from the deep awareness of I. So the first criteria regarding the deep awareness of I is consciousness of purpose. So in this articles, the creators, uh, how much creator is conscious, the initiator, the author. So the author want to connect the technical perspective with the non-technical perspectives. Like for instance, the author wants to align the innovation in stress prediction with high purpose by emphasizing the spiritual and societal impact of creating efficient, cost-effective engineering solutions. So it's the it is not only technically but also ethically and spiritual meaningful, which is bridging the gap between technical practice and divine purpose. So this is the conscious of the author regarding uh, the project, final project. The second is self-awareness. So the author know the 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 finite element method, the traditional finite element method, like the author demonstrate awareness of their role and combining technical expert with spiritual principles. Like for example, the author addresses uh, these biases, the biases in the finite element method, like there are some uh, problems with the finite element method, like times, accuracy. So the the author want to uh, overcome those problems by proposing the artificial neural model to tackle those problems and present the good solution for those problems in the form of artificial neural network model, so that can help society as well. So this is the understanding of the author regarding the artificial neural network and FEM method. Like they know what are the challenges, uh, they what are the challenges the FEM are facing, and he want to resolve those issues regarding the FEM while proposing the artificial neural network. The third one is ethical considerations. So ethical consideration is like the problem related to the FEM, like computational intensity, and also the cost of related to the FEM. The author want to resolve those issues like computational efficiency, and improving the public safety and structure engineering. For instance, like he want to predict the static stress in the bar elements using the elements S275J0 to, and when someone in the future, a designers or engineers, do design a more structure, so the structure should be safe and durable if the local people using those structure in there. uh, in their daily life. So this will consider ethical as well as the uh, local benefit for the local communities. So the fourth one is the integration of C, CCIT, Chara Chirdas Ingas Tuhan. So the author consistently remember the only one God that can maintain a coherence and alignment in all stages of the uh, research. For example, the methodology in Objective reflect a commitment to balance technical goals with ethical and spiritual alignments. This integration not only frame artificial neural network with FEM, but also reflecting the divine purpose and ethical engineering practices. So it maintains a coherence in the research while remembering the only one God. Five, Fifth one is critical reflections. The research critically reflect on how the proposed artificial neural network model affects the broader society like challenges like to reduce the time of the problem related to uh, static stress predictions and also accuracy. So the other want to resolve those issues related to the previously available method like FEM. So this reflection connects the technical innovation with societal benefits such as improved structural safety and reduced maintenance cost, like maintenance cost as well as the replacement cost as well. So aligning engineering goals with spiritual and ethical considerations. So this is the critical reflection in the of the final project. Continuum of the awareness. So other uh, has continued uninterrupted while conducted this research or this study by employing the DAI5 principle throughout the research process. So while employing the DAI5 framework, um, make him coherent and consistent in the research and from for instance the explicit exploratory discussions of scalability and future applicability reflects ongoing commitment to purpose and conscious engineering from from defining the problem to developing solutions. The framework ensures a consistent alignment of technical method with spiritual intents. So he consistent in the while conducting the research and like he faced never interruptions while conducting this research. Seven, clarity of intent. So the clarity of intent is the author aims to overcome finite element limitation while promoting safety and sustainability in engineering applications. So the article states its intent to develop a computational efficient artificial neural model while applying the DAI5 framework. So this is the clarity of the intent. You want to resolve the issues like computation, like time related to the static stress predictions and as well as accuracy. So this ensures that the research goals are well aligned in ethical and technical priorities. 8. Alignment of objectives. So alignment of objective is the other addressing the technical efficiency and societal needs. The related to the static stress predictions. Here, and he want to propose a model, artificial neural network model that is cost effective as well as the to reduce accuracy and computational efficient. So this research support ethical practices and improve access to the engineering solutions. So this alignment reinforces the spiritual and practical purpose of this study. Prevalence of intent. So the the intent of the author is uh, to lower the cost as well as the time as well related to the finite element method. So uh, related to and also uh, the challenges like the resources they are need for the finite element method. So he want to propose a model that will be the efficient, cost effective, computational efficient, and accurate. So this like we have the finite element method, that is a highly iterative simulations. So this which takes too much time. So they want to resolve that issue by reducing the time as well as the cost. So the new method to predict the stress is um, ANN to predict the stresses that will overcome those problems and accuracies as well and will benefit the local people. Sustainability focus. So as we the study is focus uh, as we discussed previously, like the FEM method are facing challenges like um, time as well as the accuracy. So the the other want to develop artificial neural model that will provide time saving to the provide a time saving alternative to the FEM, which alternatively reduce the energy as well environmental impacts. These benefits align with the study commitment to ethical and sustainable engineering practices. Focus on quality. So, like the other the model, like the other develop a model like artificial neural network which achieve high accuracy. Like the regression report shows that the coefficient of regression is 0.998, which means that the model is robust and applicable in, in other scenario as well. Similar, other scenario as well, which also means that 99 99.99% of the data is explained by the model. So this quality focused approach ensures the solution are reliable and effective in real world applications. Problem understanding, like the problem is the time and cost. Time, cost, and accuracy related to the FEM. So the study focuses on steady stress prediction in one dimension S275 G0 bar elements, ensuring the problem is well specified and relevant. This clear understanding they provide a strong foundation for the proposed solutions. So this is the problem, and they want to predict the author want to predict predict the static stress in the bore while using the alternative method. This is the problem related to the problem related to the FEM is the accuracy, time, as well as cost. So this should be need to resolve. Stakeholder awareness, while like after developing the model, like artificial neural motor, who will be benefit? So who will be benefit from this model? Like engineers, designer, and local benefits. Hmm. For instance, reducing, because why they will choose this model? Because we because of the computational cost as well as the accuracy that can help those stakeholders. Contextual analysis. The research the research places the problem within the physical and technical context of stress analysis in structural engineering. For example, it highlights how one-dimensional bar elements are commonly used in structure and construction, and how simplifying their analysis can improve engineering workflow. This context strengthens the study applicability. Root cause analysis. The root cause of analysis is FEM. FEM is the cause because FEM is as a imposed to the problem like time, accuracy, because FEM is iterative in a iterative methods that takes time, and it also need the resources. Um, there are some resources available like NC, Abacus, so which are licensed softwares. So the cost related resources like licenses also cost so much expensive. No one like normal research like can buy those licenses. So the artificial neural network will bypass these limitations, and addressing these root cause ensure the proposed solution are impactful. Relevance of analysis. The study focuses on engineering needs, local people needs. So they we want the study focus on to predict the static stress and S275J0 bar elements. So for example, the study uses the FEM generated data to train the artificial neural model, and then ensure the analysis is the grounded in realistic scenarios. This practical focus enhance the research values. So the the author generated data from the FEM analysis, and then he developed a then he developed a artificial neural model and then train and test the model. So this is the relevancies of the analysis. Use of data and evidence. So the the author generated data from FEM and then train the model artificial neural network, and then test the some data uh, um, um, from the FEM and feed their data to the artificial neural model, and then compare the artificial neural network predictions with the FEM, and find the errors. So the errors were too much low. It was about the 2.5 to uh, 2.5 to 4.4, sorry, 2.5 to 3%. So that is the error is not too much, which also the low error comparisons shows that the model is efficient and robust. Assumption, clarity, idealization. In idealizations, assumption, clarity is the first step. So assumptions, why we assume things? Because we want to make the problem simpler, to because we don't want to complicated things that will take time and cost as well. So we reduce the problem. For example, we choose there are a lot of materials available, but we choose the materials. Use, for example, use S2 S275J0 steel, which is mild steel, and we choose specific boundary conditions. So these parameters, uh, these are the assumptions. Like we choose the boundary conditions, specific boundary conditions like length, force, an area, fixed node, etc. So these are the specific boundary conditions that ensures the solution are well defined. So this clarity enhances the reliability of the proposed model. Creativity and innovations. What's there in the in this study? What's the creativity and innovation of the study? So the creativity innovation of the study is the using the alternative method to the FEM, which is the artificial neural network model integrated with the DAI5 framework, which is the modern approach to the problem solutions. Uh, for example, we apply the Bayesian regularization training method and optimal architecture to minimize the error regarding the problem solving. This innovation addresses computational challenges effectively. Physical realism. So the proposed solution adhere to like the solution we predict from the artificial neural network as related to the Hooke's laws, predicted from the Hooke laws for stress strain. Like we can see in the next slide, all the physical laws are given. Use those laws to predict, uh, calculate the stresses, and then those calculated stresses we feed to the artificial neural network, and we compare those artificial neural network prediction with the calculated one. So the values as relevant to the the values obtained from the physical laws and governing equations. Like in the next slide, we can see the governing equations. Like this one is the we use the stiffness matrix equations. These are the equations like we calculated um, the element length as well as the strain and the stresses. So this value is this one. So this is the result of the uh, from the governing and governing equations. So then we feed the result obtained from this one to the artificial neural network and predict the results. So the results were closely related to each other. So this represent the model of artificial network as robust. Align with intent. The idealization solution lies with the research intention to provide efficient and ethical engineering practice. For example, artificial neural models' scalability and sustainability reflect the study for spiritual and technical goals. This alignment reinforces the coherence of the research. Okay, scalability and adaptability. So, scalability and adaptability of this research is to we can apply the proposed ANN model to the complex problems like multi-dimensional stress analysis as well as the complex geometry as well. So this represent the scalability. Scalability we can uh, like from ship this study to the uh, three-dimensional. So it can accept the three-dimensional as well, like three-dimensional static analysis. For instance, the study suggests extend the methodology to a complex geometry, ensuring the adaptability. This scalability the research enhances the research long-term effect. Simplicity and elegance. So the simplicity of the AI is the main things in the while while developing the artificial neural model. Like we can configure artificial model in many different ways. Like we can feed the data, like when we are now in this case we are feeding two input, one hidden layer and one outer layer. But in between we can put another layer like 2, 3, 4, 5, 6, 7, etc. And within one layer we can also increase the number of neuron as well. So if we increase number of neuron, if we increase number of uh, hidden layers, that can take too much time. So that can make the problem, that can make the model not very efficient in some cases. If we increase the hidden layer or number of neurons, so the prediction result will be not that much good. Also, it will take too much time as well. So this is not a good idea. Yeah, we can increase up to some limit. We can use up to some limit if until we get the accurate result. Beyond those limits, if we increase the number of hidden layer, number of neurons, so it will affect our predictions. Beside these simplicity, we also use the training method. Like training method is the uh, Bayesian regularizations as well as the Marquardt method. So we choose the Bayesian regular. This is a simple method. Also the accurate method. So accuracy is also one of the achievement of this research. So this is so we make the problem simple. The architecture of the neural network simpler while putting the one hidden layer which composed of 8 neurons, and we use the sigmoid function like the log sig functions. So there is also a simpler one while calculating the the values. Instruction set clarity. The first step in an instruction set is clarity of steps. So clarity of steps, like it is whether logical or non logical. Like if for example, like before we like if we skip the FEM method first, so how will we train the data? So we can train the data. First, we need the results from the data from the FEM method. So for that purpose, the FEM method uh, should be followed first, then artificial network. Also in FEM, there are a lot of steps. So there are a lot of steps in the coming slides. I will show the flowcharts, how we perform the FEM and how we perform the ANN. So those are the logical steps. If we skip one of them, so we will not reach to the solutions. If we change one step to the others, so we will not reach to the solution. Like for example, the study provides detailed instructions for training the artificial neural network using MATLAB, ensures replicability. This clarity enhances the accessibility of the research, comprehensiveness. So the study cover all steps while following the DAI5 framework. Step-by-step process of FEM, step-by-step process of artificial neural network, leaving no gaps. Also following the steps of the DAI5 framework as well. This fulfill the need of comprehensiveness in the study, which makes the model robust. Physical interpretations. Physical interpretations like stress behavior in a one bar elements to interpret those stresses, how we will interpret the stresses behavior in the bar elements. That's uh, the result obtained from the artificial neural network. For instance, the comparison of artificial neural network and FEM stress prediction highlights the model applicability. This interpretation ensures the findings are meaningful, with R coefficient is 0.998, so which is too much high, almost nearly to 1, so which makes the model efficient, accurate. Error minimizations. So there are ways to minimize errors. One of those is Bayesian regularizations. The other use Bayesian regularization method to train the artificial neural network to predict the results. So while predicting the result, the, the minimum percentage such as 0.475% validate the model reliability, which also enhances the precision. So other way we can also mm, minimize the error is the to in, increase the data to feed to increase the data, and we feed those data to the artificial neural network. So then the number of samples will also minimize the error as well. Verification and validations. The artificial neural model is validated against FEM result to ensure accuracy. For example, like the regression coefficient is 0.998, which demonstrate the model robustness. This validation strengthen the study credibility. Iterative approach. This method improved the iterative uh, approach, the iterative simulation in the FEM, uh, because this study overcome those problems like the FEM mostly work on iterative approach, so which were more exposed to the time taking and accuracy as well. So on the other hand, we have artificial neural network, which improves those iterative simulations, such as multi-dimensional analysis. For example, future research is proposed to apply the methodology complex geometries. This iterative mindset ensures adaptability. Sustainability integration. Sustainable. The model is the other develop a model, and this study is sustainable because it reduces the time as well as increase the accuracy. So this is all about the sustainability of this study. Communication effectiveness. So the findings are prescribed clearly, supported by visual aid like regression plots. For for example, flowchart illustrate the FEM and artificial neural network workflows ensure the comprehension. This effective communication enhances the research usability. So they're in the proper flow, like the FEM is working on and artificial neural network work on. So the flow of the information is given by in the next slide. So these are the this one is the flow chart for the finite element method. Like first we need these variables, then we mesh them, discretize the domain, and then we initiate the stiffness matrix and force, and then we calculated the local stiffness, and then we assemble, then we apply the boundary condition, then we solve the equations For the deformation, then we calculated the stresses and the element and the bar element, and we then show the. So these are the steps, step by step information we did that we need to follow to get this one. If we ship like from this stage to this one, so it will not work. We interrupted the process. Like the same is for the uh, sorry, I included both of them. I will show you the other one. uh, I will show you the other one here. This one. This is for the artificial neural network algorithm. So if we skip any of this step, the artificial neural network model will not work. If we changes the position of one strip to this one, so it will also not work. Like we first load the data, then we divide the data into the input and output, then we normalize the data, then we define the configuration of the network, and then we divide the data into training, validation, and testing data. Then we train, then we test the network, then we again ship, converting the data into the normalized form. Then we calculated the performances, then we show the save the artificial neural network results. And so these are the flow chart, how the information going from start to end, right? So this is all about the uh, flow charts. Alignment with the DAI5 framework. So the research maintains coherence because we apply DAI5 approach to solve the problem, to approach to the solutions. This is the new modern approach to solve the problem. Like this study, the DAI5 principle mainly focuses on the integration of ethical, spiritual, and technical uh, things, technical consideration. Sorry, like the DAI5 framework mostly integrates ethical, spiritual, and technical consideration in all stages. So spiritual as self-satisfaction, technical as the problem related to the FEM method, ethical is like they provide the solution for the local communities, they will benefit from them. So this is the main thing DAI5 framework deliver us to integrate these three things: ethical, spiritual, and technical. Right? Spiritual is related to the personal this is subjective, right? And technical is like to related the problem related to the uh, technical issues like FEM method. So the technical consideration will benefit the engineer, expert, designers. Spiritual will benefit the author as well, and ethical will benefit the all people, uh, the engineer, expert, and local community as well. So the diaphragm is more emphasis on these things. So the other focuses is on and integrate these considerations in all stages of the research. So which make the study very strengthened. Document quality. The last one is documentation quality. So the the professional like the article provides professional documentation while following step by step information provided by the uh, uh, DAI5 framework. So the author followed the DAI5 framework, and also the step by step flow of the information for the finite element as well, artificial network as well. So let's maintain the quality documentation. Like the author start from the beginning, then goes down. First he discuss the complicated things related to the problem related to the. First he started from the conscious thinking, conscious purpose. What is my purpose? The author. So then last he just read, then he discussed about the problem as well, complicated thing, then make the problem simpler. So lastly he reached the goal and develop a model, artificial neural model. So he discussed all those things in the article. So this make the article very qualitative. So this is all about the documentation quality, and all about the 33 criteria of the evaluation for the final projects. So thank you. If you have questions, so you can put a comment in the comment section of the my YouTube channel. So I will definitely answer your questions. Thank you so much.